Hello and welcome. My name's James Bouckley. I'm a content developer at Unity Technologies. I work on the R&D content team. It's our job to make demos, tutorials, that sort of thing. Has anybody ever attended a training day at Unite? Woo! Some people. So I did those, but we don't do those anymore. So sorry about that. So this talk is extending timeline with your own playables. And what does that mean, and why do you care? So timeline ships with a number of playables that you can make by default, things like Cinemachine, audio, animation, and things. We want you to be able to do whatever you want with timeline, so we need you to be able to extend it. And this talk is about how you're going to do that. So it's split into 4 sections, the first of which is going to be me explaining a little bit of background about what timeline is doing behind the scenes. Then we'll be running onto the scripts that you actually need to create in order to extend timeline. After that, I'm going to talk about the Timeline Playables Wizard, which is a tool that's been made so that it can create parts or sometimes even the entire scripts for you so you don't have to write as much code. And then at the end, we'll do some questions. OK, so the first topic that we're going to talk about is understanding timeline. So how many of you here went to any of the other timeline talks that have been on so far? Wow, pretty much everybody. OK, so you've heard the term playable and you've heard the term timeline a lot, and they're probably a little bit confusing and sound a little bit interchangeable. Basically, the difference is playables are things that are related to time in Unity. So an audio clip that's related to time, you need to know what time is playing at, and that's a playable. An animation that's dependent on time, that's a playable. We want you to be able to make your own playables that sit on timeline. But the trick is, timeline itself is also a playable, so you can have timelines that sit on timelines. So timeline is a graph, and I don't mean that kind of graph. What I mean is that kind of graph. So this is showing off my amazing paint skills. On the left at the bottom there, we've got 3 animation clips, and they're feeding into an animation mixer. That animation mixer is deciding what sort of animation the final thing should be playing based on the timing of all those clips and how it's been set up. It's then feeding that into the timeline, and that timeline is then feeding it through to the animated component. So that's doing one side of it. Then we've got another track on the other side. That's going to have audio clips. They get mixed together using an audio mixer. That's getting fed into timeline, and then the timeline's feeding it out to an audio source component. So this is basically what timeline is doing behind the scenes. Rather than thinking of it as a timeline where it's chopping it into various sections of time, what it is, it's creating this graph behind the scenes, and then based on the time that it is running through that timeline, it mixes them in different ways. So a little bit counterintuitive. So timeline is a graph, but timeline is also a template. Don't have a picture of that, sorry about that. So what do I mean that it's a template? What I mean is the things that you're seeing, they're not what it's actually doing. It's creating that graph whenever you change anything. So they've got this static graph that's staying exactly as it is. Anytime you change anything, it's tearing that graph down, creating it again, so that it knows exactly what should be playing at any time based on the mixes that you set up. OK, so now we'll get into the meat of it. And the meat of it is the scripts that we're actually going to be creating to extend timeline. And there are 4 of them. The first thing that we need is the data that you're going to actually use for your timeline. So in the case of an audio clip, for example, this would be the actual sounds, the sounds that you get out of the audio clip. Then the next script that we need to create is the clip itself. That's the thing that sits on the timeline. It contains the data, and it's the thing that you move around, and you've seen probably at the other timeline talks. The next one is the mixer. So if you remember just looking at the graph just then, all of the clips, they feed into the mixer. The mixer decides what actually is the result of that. Then the last thing that we need to make is the track. And the track is what contains the mixer. And it also handles the output. So once the mixer has done its thing, it then feeds into the track, and the track decides where to go. OK, so let's look at these things in context. We've got a picture here of a timeline, very, very simple one. And there's an audio clip at the bottom there. And within that audio clip, I've drawn a little red box to symbolize the data. Then we've got the clip. That sits on the timeline. That's the container for it. And you can move the clip back and forward. The clip contains all the data about the timings and that sort of thing. Then there's the mixer. The mixer is going to contain all of the clips. I realize now that this is a pretty bad example because there's only one clip. But if you imagine this box drawn around the top thing, that makes a lot more sense. Then we've got the track itself. And you can see on the left-hand side of the image there, there's an output. It's the track binding. And this is where all of the information from your track is going to go. So let's have a look at some examples. So the first example is the data. So you'll notice at the top there, in brackets, I've put behavior. Now, all of these scripts, these 4 scripts, they're all relating to one type of playable. There's one thing that you're trying to achieve here. So that's going to be the start of the name of each script. But then because each of them is different and they need a different name, we need to name them based on what they're doing particularly. So the data works a little bit like a monobehavior. It's the normal script that you've seen in Unity. And it also inherits from a class called playable behavior. So the suffix that we're going to give this particular type of class is behavior. So that's not mandatory. That's just something that we advise you do because it makes it a lot easier to understand when you see 4 scripts next to each other with similar names. You need to know which one is the data, which one is going to be the clip, etc. So as you can see, there's some data stored here. We've got a transform, and we've got a couple of bools. And we've also got a function called onGraphStart. So that's going to work like the start function of a monobehavior. When the timeline starts, onGraphStart is called, and you can do whatever you want. Here, we're just checking that the duration of this particular playable is not 0. If it's 0, then you can't really tween, because as you can see from this example, it's the transform tween behavior, and that's what all our examples today are going to be based on. Something I want to flag up here is there's a transform here called endLocation. Now, you may or may not be aware that timelines and all of the things that belong to timelines are assets. Now, assets in Unity cannot reference scene objects under normal circumstances. But let's say we want to tween between 2 objects in the scene. We need the asset to know about those scene objects. So we need to use a special system that's been invented for this, and that's called exposed references. We'll be coming back to that a little bit later, explain how those work. So the next one is the clip, and in brackets clip, because that's the suffix that we're going to give it. We can see that this inherits from playable asset, and that's the one that you need to inherit from if you're creating things that need to sit on a timeline. So when we're creating something that's going to have data and it's going to sit on the timeline, we need to inherit from playable asset. We're also implementing iTimeline clip asset. And what that does is it lets you have the clip caps, which you can see about in the middle of the script. So the clip caps, they influence the way that the timeline is treating your particular playable. So you can see in this case, we've got blending. And what that means is each clip will have ease in and ease out curves, and will allow them to overlap. And it will affect the weighting of those clips based on whether they're overlapping or whether they're easing in or easing out. There are a number of different clip caps. I'm not going to go through them all here, but they're in the documentation, so you can check them out yourself. OK, at the top of the script, there is a transform tween behavior. So that is the data that we just saw. And this transform tween behavior is called template. Now remember I said that everything that the timeline does is a template for other things. It's creating something from what you've made. So this template is going to be the thing that gets duplicated whenever you create a new version of this graph. So whenever the graph needs to be torn down and start again, we need to generate the new data from something. And that's what this template is going to do. So whenever you click on a clip in the inspector, then you see on the right the information for that clip. And it's going to have the exposed reference that we've got there, and it's also going to have this template, because this template is the data that we want to use per clip. Whenever the timeline actually works, whenever it's actually playing, it's going to generate a copy of that using the create playable function, which is the thing that you can see at the bottom of the script there. So there's a couple of lines in there relating to exposed references, and we're going to come back to those a little bit later again. But for now, the important parts are that it's creating a playable using the graph and the template. So the graph is the thing that we saw before. The timeline represents a graph, and we need to know where to put this playable in that graph. And we're creating it from the template, so we're creating a duplicate. OK, next is the mixer. Now, this is the real important script. This is the thing that you will want to do differently. Everybody will want to do it in a different way. And it also inherits from playable behavior, but it's treated in a very different way. So in this case, we don't want any data. We just want to use the process frame function. So the process frame function is called once per frame, like update, and all it does is it takes in all of the information from all the clips, and then we decide how to blend with them. So let's run through the code here. First thing we're doing is we're storing a new transform called track binding as a cast of the player data that's passed into this function. So remember, this example is transform tween. So we're moving a transform in the scene. That's the thing that we want to affect with our playables. So we need a reference to the transform we want to affect on the track. So that's what that is. It's finding the transform that we're affecting so that we can actually output to it using the mixer. If we haven't found a track binding, then we don't need to do anything, so we're returning. But assuming we have found a track binding, we actually want to start doing some blending work. So the next thing we need to do is find the input count. Now, the input count is how many clips there are on that track. So if you have 15 clips, then the input count is going to be 15, and you'll be able to iterate through all of those using a for loop, find the various clips, find their data, and then from that, you can decide how you want to affect information. Now, in this case, I've just put a little comment ... because everything is going to be different. Like for a transform tween, you probably want to work out how far it is between your two starting points and endpoints, and then take an average or something like that. But I'm not going to tell you how to do it in this because it's going to be different for whatever case you want to come up with. Lastly is the track. So this looks complicated, but it's actually not too bad. The first thing to notice is inheriting from track asset. That's going to allow it to be a track. Seems pretty straightforward. Then the important function is the create track mixer. And all that's doing is it's just creating a mixer of the type that we've given it. So transform tween mixer behavior. Oh, yeah, sorry. With the last one, mixer behavior was the suffix that we chose. And this one, track, is the suffix that we chose. So the important thing to notice about this script is the three attributes that we've got at the top. First one is the track color. So you may have noticed that in timeline, playables have a colored stripe on the left for their track and at the bottom for each clip. You can choose what color you want your clips to be, so that's how you choose that. We need to know what this is going to be a track for, what's it going to have sitting on it. So we use the track clip type there to set which type of clips we want to create for this track. And finally, if we want to output something output something into the scene, then we can optionally choose a track binding type. Now, most of the time, you're going to want a binding type because you want it to output something somewhere. And in this case, we're outputting to a transform because we want to move it. This is a transform tween after all. So the one function that I've not discussed yet is the gather properties function. This is related to preview mode in the timeline, and we'll come back to that again a little bit later. So a quick summary. We've got the data, which has the suffix behavior. Now that's the information that you want to use. We've got the clip. That's the thing that sits on the actual track. We've got the mixer with the suffix mixer behavior. That's the thing that takes in all of the clips, mixes them together, and produces an output. And then the track itself has the mixer on it, and it handles the output. So the next thing we're going to talk about is the exposed references. As you may remember, we were talking about them earlier. We want to be able to affect things in the scene. So normally, assets can't do that. But the way we get around this is that we store the reference that we want in the director component, which is the component that plays the timeline. When the director component gets given a timeline, it's allowing slots for any bindings that are required. So any exposed references or track bindings are stored in the director, and whenever you switch director components, it will just pick up whenever you switch the timeline that's allocated to the director component, it will pick up the references that it needs based on what you set last time. So in the example that we had before, we were moving a transform tween, so we need to know where we're moving to per clip, because each clip is going to move it to a different place. So that's going to be an exposed reference. That needs to be stored on the director component. It's also, the director component also needs to store the track binding, but it does that without you having to worry about exposed references. So this is the clip script that we saw before. And there are a number of things that you need to do in order to work with exposed references. First thing is that you need to actually store one. So at the top, you can see there is a public exposed reference, which has got the generic type transform. And we've called that end location. So that's what we'll actually be assigning. We'll be dragging and dropping, in the inspector. We'll be dragging and dropping onto the exposed reference that you can see there. Then, whenever we create a playable, we're getting the clone that we've just made of the behavior. So we're creating a playable, and then we're getting the behavior from it. And then the behavior itself has a reference. It needs a reference to that transform in the scene. So it's got a variable itself called end location. And then we assign that by saying the exposed reference end location dot resolve. And the resolver that we use is the one that belongs to the graph. So I know that's a bit difficult to get your head around, but basically, just copy those lines. It's easy. And you can see this is the data, this is the behavior script, and it's got that transform end location. So the end location there is going to be assigned by the clip when it's created. And then since the behavior has it, the mixer is taking in all behaviors, and then it can use the transform that has been assigned. So therefore, the mixer is able to use references to things in the scene. OK, so the next thing is preview mode. That was that complicated function that we just talked about beforehand with the track. So what is it, and why do you care? Well, the timeline needs to be previewable. You don't want to have to press play every time you want to check your timeline, because it might not be the start of play mode. You might have to play through everything to get to that ending cutscene in order to test it out. You don't want to do that, so you want to be able to preview it in edit mode. But if you're previewing something in edit mode, that means it's changing values on components in the scene. So it might be moving a character, it might be playing something, it might be setting any number of things. And you don't want that to actually affect your scene. Because if you go halfway through a timeline and then everything's moved, and you click save, all of a sudden you've got a scene that's totally broken because it's halfway through a timeline. And you can't back that out. So we need to be able to preview it. We need to be able to say, don't listen to these things. These things are being driven by something else. These things are not going to be savable. They're going to be driven by our timeline. So when you're creating your own playables, you need to be able to tell the scene, these things are being driven by me, ignore them for now. So that was the complicated-looking function in the track. And again, this is not something that I'm really going to go into much, because it's exactly the same for pretty much whatever you want to do. All this is doing is it's creating a serialized object for your component, or whatever you're affecting, and it's iterating through all of the properties on that component, or the serialized properties, I should say, and it's saying to the driver, so remember these are driven properties, it's saying to the driver, don't change this, or don't save this, it's being driven. So when preview mode is off, then it's allowed to save everything. When preview mode is on, then it's not going to listen to these particular properties. OK, so this is the last bit of script that we're going to look at for now. It's the custom GUI. So under normal circumstances, when you click on a clip, you're looking at that clip. So you're going to have a few object references for your exposed references. So in our case, we've got the end location, which is a transform. So it's just going to look like end location, object field. And then the next thing that you're going to have is template, and it's going to be in a drop-down, and then all of your additional information is going to be there, and it's going to look really horrible because you've got another end location, and it's just not going to look very nice. So what I recommend is creating a property drawer for your behavior. So if you create a property drawer for your behavior, then whenever the inspector tries to show your behavior, so immediately after exposed references, then it's just going to draw it normally. So it's going to look nice. It's going to look like a proper script. So a couple of things to note, that this is targeting the behavior, that's the data part, and that I've missed off deliberately the end location that's part of the behavior, because it's the same as the end location, which is the part of the clip. The clip one has the exposed reference, which we're assigning to the data, so they're the same thing. We don't need to show them twice. OK, so the next thing I want to show you is the timeline Playables Wizard. What is it? Why do I want it? Where can I get it? So I realized that writing 4 scripts to make one playable is a bit much. So what I decided to do was make an editor tool that would write some of the scripts for you. Because if you want to choose an exposed reference type, you can just put that in GUI. Then it's going to be assigned to you by code that's going to be exactly the same. A lot of this code is all going to be boilerplate, like the gather properties function is going to be exactly the same whatever you do. So the only thing that actually changes is the different data that you need and how you mix it. And if you can choose most of that from an editor tool, why bother writing the scripts at all? So I thought it'd be nice to make something so that you guys don't have to write so much code. And in some cases, it will even write the blend code for you so that you don't have to write anything at all. Currently, you can't get it anywhere, but it's going to be on the asset store pretty soon. It needs some testing first, and hopefully it won't blow up when I demo it. But I'm sure everything will go fine. OK, so now I need to switch over here to duplicate these displays. Changes. I'll go to Unity. So in order to use the timeline Playable Wizard, all you do is you go to Window and select Timeline Playable Wizard. So this is what you'll come up with. And what I'm going to do is run you through all of the settings here and how to use them. So at the top, we've got a Show Help checkbox. I'm going to leave that off for now. If you turn it on, then it gives you help on what all of the different features are. But that's kind of my job to run you through these, so don't want it busting on my stuff. Next is the playable name. So in this demo, I'm going to make a particular type of playable. I want something that affects the various properties of a light, because I think in order to affect a light, I shouldn't have to make an animator and animation clips and have to worry about all that for just changing the color of a light or something. So I want to control a light. So I'm going to call it light control. Control. And that's going to create all the scripts that we required with the suffixes that we discussed. So it's going to have light control behavior, light control clip, light control mixer behavior, and light control track. So the next setting here is standard blend playable. Now this is a special type of playable that is less flexible, but in exchange for it being less flexible, the wizard will write everything for you. So you don't need to even open Visual Studio. For now, I'm going to leave that off, but we will come back to it a bit later. Next, we've got the track binding type. So by default, it's on none, but I probably want to affect something like a light component. So I'm going to choose light. And we can add exposed references. So these will get added to both the data and the clip as their various types, and it will be set up to automatically assign them for you. We can call that whatever we want, so I'm going to call it my lovely reference. And you can add as many of those as you want, and you can choose their type accordingly, whatever you like. I'm going to remove those for now because my light doesn't need to reference anything in order to change its color, but let's say I wanted to change its color based on the material of some renderer. Then I could get a reference to that renderer and change the color based on that. Next, we've got behavior variables. So these are distinct from the exposed references in that they are specifically part of the behavior, the data. So in our transform tween example, they were things like the bools that said whether or not we were going to tween the position or the rotation. I might want to float for speed or something like that. And you set them in exactly the same way as the exposed references. Let's say I want to float, so I'm going to go down to there, choose float, and then I'm going to call it speed, something like that. I'm going to remove that for now. Next, we've got the clip caps. So these are the ways that your playable can be treated by timeline. You can set these as you wish, and it'll deal with them as appropriate. Next, we've got the track color. So I think for a light, a nice yellow color would be about right. But you can choose whatever you'd like. And then there's, lastly, a checkbox called Create Drawer. So if you want, then I can create the, this tool can create the drawer that we saw before that automatically knows which ones are behavior variables and which ones are exposed references and how to treat them differently. So there is a catch. This wizard is only generating scripts. It's not editing them at all. So if you use this to create a drawer and then go back and add some more behavior variables, add a new exposed reference or something, the drawer isn't going to update. It's not going to know about that. You then have to go back into an IDE, like Visual Studio or something like that, and update that yourself. But it's still a step forward. OK, so that's a normal operation. But what I'd really like to show you is the standard blend playable. So the idea with this is when I was making some default playables, which is something that's going to ship with the wizard, I noticed that a lot of the playables that I was creating are just changing the properties of a component, and all the blend code is very predictable. So what I decided to do was add these to the wizard, which allow you to completely create your playables without having to write any code. So for our light example, I want a track binding type of light. And whenever I create a playable, what it's going to do is it's going to override the values that are currently on the component that we're targeting. So let's say we're targeting a light in this case. Now, in my game view, you can see I've got a lovely blue light, and it's been lit up really, really well. I'm sure Dave is not cringing at all. Dave's the artist on my team. So I want that as the default, and so I'm going to use my sign light as the default values for the playable whenever a new clip is created. So it's going to have a nice blue tinge and the values for whatever I want whenever I create it. So now, instead of creating things like I want a speed or I want something like that, I need to choose the variables of the component that I want to override. So what I'm going to do is click Add, and then I want to override the color of a light component. I also want to override its range, and I think intensity is another good one to override. So what this is going to do is it's going to allow me to create playables which don't do anything to the component that they're outputting to until they're reached. And then they're going to nicely interpolate to whatever values I set for each clip in the inspector. So let's hope this works. Hey, it worked. It's almost like I practiced this and I knew it was going to work. OK, so we've got a new folder called Light Control here. And as you can see, it's created a number of scripts for us. And what that will also allow us to do is add a light control track to our timeline. So I want to output this timeline to the sign light. And I want to be able to create some light control clips. So I'm going to have it start after about a second. I want to blend in a bit and fade out a bit. And I want to change the color to something's gone wrong pink. OK, I'm going to drop the range a little bit, and I'm going to drop the intensity a little bit, so it should fade out and into a nice pink color. And then fade back to blue. So you can do all of that without writing any code, and you can do it for any component that you want. What's more, it doesn't just blend floats and colors, it will also blend integers, and it will even blend things like strings and enums. Because essentially what you want to do, if you have multiple playables and you want them to have text, then you just want whichever playable has the heaviest weight. Which one is the most important at that time? Choose the string from that, choose the enum from that. So part of the default playables package that's coming out will have a component that will be ideal for things like subtitles. And the light control and a number of other ones, they're all made just using this wizard, and there was no other code written. So next, what I'd like to do is briefly show you the code that was created. So as you can see, it's created some pretty straightforward code. It's given us a color, range, and intensity. And these are the values that we gave it in the wizard. So we said that we wanted the sign as the default, and it was also going to be the thing that we were overriding. So by default, whenever you create a clip, it's going to have a color and a range and intensity as assigned here. This is the code for the clip that's generated. And as you can see, it's very similar to the robust example that we saw before of the transform tween. So something to note about standard blend playables is they do not allow you to use exposed references, because the whole idea about them is that they will write everything for you. And if you use an exposed reference, then the wizard no longer knows what you want to do with it. So you can't do that. I just don't let you. If you want to use an exposed reference, then you're going to need to use the wizard in normal mode, and then write the mixer yourself. So let's have a look at the mixer behavior. So this is the stuff that I cut off the slide before. this is how to actually blend your code. So we've got some private values for the default color, the one that is going to be at the start. Whenever the timeline first starts, it's going to check whether or not the first frame has happened. And if it hasn't, then it's going to assign the defaults based on the track color so that it can revert to something. Then what we're going to do is find out how many inputs we have. And we need some variables for the blending of our different properties. So we've got a blended color, blended range, and blended intensity. And we've got these two weights, the total weight and the greatest weight. And these are what it's going to use to blend and assign various properties. We're going to loop through all of the inputs. And for each input, we're going to find a weight, get the input playable, that's the clip, as it were, and then from that, find the behavior itself. Once we've found the behavior, we can assign to the blended version of the property based on whatever was in this particular clip. And then once we've totaled everything up, we can simply assign it back to the track binding. So that's how that works. Finally, once the graph stops, we want to make sure everything goes back to the way it was. So we set back, first frame has no longer happened because it stopped. And the track binding has its colors assigned back to the default. I will briefly show you the track script, but there's not a whole lot to it. So it's picked up the color that we set in the wizard for the color of the track. It's decided that we want the light control clip as the type, and we've got a track binding of light. Then the mixer is just being created using the mixer type that we set out. And we have the exact same gather properties function as always. It's exactly the same no matter what you're making. So all you're doing is you're gathering up the properties from the component and then making sure that they are assigned to the driver, which is this line here. I have rushed that a little bit. Sorry about that. But has anybody got any questions?
Actually, I have a question. I don't know if it makes a lot of sense, but I'll try to. Can you control the timeline playback from a clip? I mean, can you jump from one point of the timeline to another point of the timeline with a clip?
Yes.
Yes, you can. So, and can you like evaluate a condition within the clip, referring some object? I mean, let's suppose I have an object on the scene. And if a collision in that object occurs, that clip within the timeline will make the playhead jump to another site on the play?
Yeah.
You can do that?
You just need an exposed reference to find the object in the scene that you want. And once you've got that exposed reference, you can do whatever you'd like with it in the mixer.
Oh, that's cool.
And you just check, has that scene object had a collision? Yes. Jump to this point.
Cool. And the last question is, can you control the playback rate of the timeline within a clip?
So the playable director component controls the time that the timeline is going through. You can set that to manual and then update it yourself whenever you'd like. So in that way, you can have it run in sync with whatever thing you want, like late update, for example.
Oh, thanks.
Cool.
Hello. With the clips, you have those variables like color, range, intensity, and I guess if you have an exposed reference, that also shows up there, I guess, right? Just to be clear.
So for that example, we were working with standard blend playables. So with standard blend playables, you can't have exposed references because they're the type that will completely write the code for you. Okay. And in that sense, we don't know what the exposed references would be for. Okay. So they're not allowed. You can still use exposed references in the normal
Yeah.
settings for the wizard. You can make anything you want that way. But given that you're using exposed references, you then have to write the blend code yourself because it's undefined what you would like.
And for example, in the standard wizard the thing with the color and intensity, could I grab a reference to this at runtime and perhaps change the color that it would blend to when I wanted to?
So you can get references to clips at runtime,
Yeah.
but it can be quite a costly operation.
Okay.
So you'd probably want to find another way of doing it, because what you have to do is go through all the bindings, find the graph, find all the clips from that.
Okay, cool, thanks.
Hello.
Hello.
Can the clip or can the clips in general control their own default length based on the data? Like, for example, if you have an audio clip with some actual wave sound in it that has a length, and if I then just put this clip into a timeline, can it define its own default length?
So this actually brings up something that I meant to mention at the end, but I forgot to. So unfortunately, the timeline API is probably going to change a little bit, because what you saw there was complicated, really complicated. Like 4 scripts to write one thing it's a bit out there. So the API is going to be updated, and the wizard will update with it. And from that, you'll be able to set defaults when that API change comes in.
Okay, and another thing, similar direction, could it be possible then to have, like, if I have multiple clips, one after another, they all define their own length, and if we stick with the example of audio clips, if I switch one of them, can the timeline flexibly or dynamically change where they start and end because of the change of length of one in the middle, for example?
Yes. So with audio, for example, when you drag those in, it will give them a default length of however long the audio clip is. But then you can use the clip in, clip cap in order to have a setting to allow it to start halfway through or something like that, if you want.
Sounds good, thanks.
Cool.
Hello.
Hello.
I have a question about binding to a track and exposed references. Like, I'm a bit unclear about kind of what the difference is, and also how you were accessing the bound object to the track at the end there, because you had like a member variable m underscore, like the bound object, but I'm not quite sure where that was in the script.
Yeah, hang on, let's bring it up. So you were talking about the mixer, right?
Yeah.
So the track binding is the player, hang on, it's a little bit off the screen here. It's the object called player data that's passed into the process frame function. So from there, I've just got a light reference here, and I'm just setting it in the process frame function.
Great.
So super easy.
Thanks.
Did you want to know? Sorry, did you ask about exposed references
I guess
as well?
the other thing was, yeah, if that is an object that's attached to a track, then the exposed references are, I guess, variables you want to affect in the clips. Is that correct?
Yeah. So exposed references are generally per clip. They are the sort of things that would affect you on a per clip basis. So, for example, when we were looking at the transform tween, we want to know where that particular tween is heading to. So it needs an exposed reference for its end location. But the thing that we're actually moving is a sort of one per track thing. So that's going to be the track binding. Cool?
Cool. Great. Thank you.
Awesome.
Is there any support for single frame events specifically? Because all of the clips have blending and they attach to each other. But for example, if you would want to create a tree falling on a bunch of units, dealing damage to all those units in that area, would it still be like a clip that you can scale, or can you force it to only be a single frame?
So you can have single frame clips, but there is an event track. I don't think it's released with 17.1, but I think it's going to be released with 17.2, which is exactly as you would.
And that would be expandable with your own extendable, but your own event center.
So the way it will work is that it will say, there is this event happening, and you subscribe to that event to listen to it and say, oh, when that event happens, so your tree falling down, you'd say tree falling down event, and then whatever you wanted to listen to that, so a mono behavior in the scene subscribes to that event, and then you can have that working.
Thank you very much.
No worries.
Hey, first off, I think it's great to have this timeline and the playable assets and so on. And one of my questions is, why do you change the API again after you changed it in, I think, 2017 beta 4, after the preview was released? And also there is one type of thing, like basic playable behavior, I think, where you can just create it with one thing that you are also using in your example files. So I was asking first is, why didn't you present also the basic playable behavior first off? And the second is, how do you plan to change the API again?
Okay, so this is the bit where I can dust my hands of it, because I'm not a dev on it. But basically, the basic script playable that you're talking about is a Unity object. And the idea with playables is they're extremely fast and efficient. And Unity objects have certain defaults that need to be set, and they have various weights that is going to slow it down. So if you wanted to make a massive, massive, massive timeline that used Unity objects, it might start to chug a bit, whereas the current implementation is extremely fast.
No, but I think it's the same implementation just with basic at the start, like this one. And you're using it in the examples, but it's slow.
Yep.
So
it's because the examples were written before this API was introduced. And then this API is really fast, but it's really cumbersome.
Ah, okay.
So the sort of abstraction layer on top of this API hasn't been written yet. Well, it has been written, but it didn't make it the cut.
Okay.
So I'm really hopeful. Like, I can't speak for the devs because I'm not one of them, but I'm really, really hopeful that 17.2 will have a new API which is a lot more simple than this.
Thank you.
Okay. Thanks very much, guys.